All right, today for day 8, we're going to go through this worksheet on the video. So follow along, take notes, and then pause when asked to. So it says, given f of x is 4x minus 1, write a function g of x whose graph is a translation of 3 units up of f. So what that means is we have this parent graph f of x. You can see it graphed. And we want to write a function g of x that is f of x plus 3. So we start with our function f, and we're going to translate it up 3, so that's why the plus 3 is on the outside, because that's what moves it up. And then we plug in for f of x. F of x is 4x minus 1, and then we have our plus 3, and that leaves us with 4x plus 2. And then we're going to check it graphically. If we come over here and graph it, our y-intercept is 2. We're going to go up 1, 2, 3, 4 over 1. Connect our points. And notice that every single point on F is shifted up 3 units.
Why did you choose?
So for part B, it says to write a function h of x whose graph is a translation of 2 units right of f. So if you think about what do we do to show 2 units right, that means that it is moving horizontally. So we know that plus 2 or minus 2 needs to be inside. To show 2 units to the right, that means we need to undo subtraction to add 2. So inside, it's going to be x minus 2. Because think about, how do we undo that operation there? We add 2, which that's what moves it 2 to the right. So now we go and evaluate our function f. So f of x minus 2 tells us to go to function f. Anywhere we have an x, we're going to plug in x minus 2. And then we simplify this. So I'm going to distribute. I get 4x minus 8 minus 1, which leaves me with 4x minus 9. Okay, and then again, we can check that graphically. I'll just do it on the same exact graph. So we have a y-intercept of negative 9, 3, 4, 5, 6, 7, 8, 9, slope of 4. And what you want to see here is that every single point was shifted 2 units to the right. And this is our h of x. So that's the big idea of today, is doing transformations and translations to a graph that is given. Okay, so for this next one, number 2, we're going to be given f of x equals the absolute value of x minus 4 plus 2. The graph is shown to the right. Letter C, it says to write a function g of x whose graph is a reflection in the x-axis of the graph. And then it says to check graphically. So in the x-axis of the graph, same thing as over the x-axis. So that means that it's a vertical reflection. And how do we know we have a vertical reflection? Is because there's a negative in front of the function. Okay, so you just have to be a little bit extra careful. So we want the opposite of f of x. So what is f of x? It's the absolute value of x minus 4 plus 2. So you got to think about it. Okay, I have to distribute this negative to the absolute value part as well as to the plus 2. So that negative is going to be in front of our absolute value. And then instead of plus 2, it's going to be minus 2. And so when we graph this, we should see that v up there is reflected over our x-axis. And think about this. This transformation is going right 4, down 2 instead of up 2. So there's your vertex. And then instead of opening up, it's going to open down. So you can see with this graph that yes, It is a true reflection over our x-axis. All right, and then for D is h of x. It's a reflection in the y-axis of the graph, which